Dear students, welcome to Blackboard. In this video, we are going to discuss Chapter 6, Triangles. Similar figures. Two figures having the same shape and not necessarily the same size are called similar figures. Congruent figures. Two figures having the same shape and same size is called congruent figures. For example, suppose we are taking copies of our photograph. If we are taking the copies of same size, they are congruent figures because they have same shape and size also same. So they are congruent figures. If we are taking the copies of our photograph with different size, they are similar figures. Not all congruent figures are similar, but the similar figures need not be congruent. Then another note, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio, that is proportion. Two polygons, what is meant by polygon? Polygon is a closed figure made up of line segments. Triangle, quadrilateral, all are polygons. So here it is saying two conditions to be satisfied by a polygon for it to be similar. The first condition is their corresponding angles are equal. Second one is their corresponding sides are in the same ratio, that is proportion. Fill in the blanks. All circles are dash congruent, similar. We know all circles are similar. Circles drawing with the same radii can be congruent. Second question, all squares are similar or congruent? The answer is similar. Third question, all dash triangles are similar. Isosceles or equilateral? The answer is equilateral. Similarity of triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio, that is proportion. So we can say two triangles are similar if first condition corresponding angles are equal. There are three angles and that three corresponding angles should be equal. And the second condition is their corresponding sides are in the same ratio. The ratio of their corresponding sides should be equal. Note, if the corresponding angles of two triangles are equal, then they are known as equiangular triangles. A famous Greek mathematician Thales gave an important truth relating to two equiangular triangles, which is as follows. The ratio of any two corresponding sides in two equiangular triangles is always the same. That is, in two triangles, if all corresponding angles are equal, then the ratio of corresponding sides are also same. It is believed that he had used a result called basic proportionality theorem, now known as Thales theorem, for the same. Theorem statement. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Here is given a figure also. I have drawn the same figure. In the corner you can see triangle ABC. And it is given in the statement, if a line is drawn parallel to one side of a triangle. Here you see DE is a line which is drawn parallel to side BC. So these lines DE and BC are two parallel lines. This line DE intersecting the side AB at the point D and the side AC at the point E. Then we have to prove the other two sides are divided in the same ratio. The other sides are AB and AC. It is divided in same ratio. Here the ratio of the side AB is AD by DB. Ratio of this side AC is AE by EC. So we need to prove AD by DB equal to AE by EC. So let us read the statement once again. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. First, let us write down what is given. A triangle ABC in which a line parallel to side BC intersects other two sides AB and AC at D and A respectively. To prove AD by DB equal to AE by EC. Construction. First one is join BE and CD. In the figure you can see this is triangle ABC and this line DE parallel to BC. We have to join BE and DC. One more construction, draw DM perpendicular to AC and EN perpendicular to AB. That is, we needed to draw the perpendiculars for the sides AB and AC. The perpendicular line to the side AB is EN. The perpendicular line to the side AC is DM. This is very important. The perpendicular line to the side AB is EN. The perpendicular line to the side AC is DM. Now proof. Area of triangle ADE equal to half into AD into EN. Here you see this is our triangle ADE. Triangle ADE has base AD, height EN, because we just discussed now EN is the perpendicular line to this whole portion AB. So EN is the height for this triangle ADE. And we know the formula to find out area of triangle, it is half into base into height. Therefore, area of triangle ADE equal to half into AD into EN. Then next triangle BDE. Here base is BD. Height is same because it is the only perpendicular line to this portion. So height is EN. Therefore, area of triangle BDE equal to half into base into height, that is equal to half into BD into EN or DB into EN. Next, area of triangle ADE equal to half into AE into DM. We are considering triangle ADE again. This time the base changed. In the previous case we have selected the base AD. So the height was En. This time we are going to select the base in the other side. It is AE. Base is AE. So the height is DM. And the other triangle is triangle DEC. Here base is EC. Height is same for the triangle ADE. It is DM. Because we can draw only one perpendicular line from one point to a line segment. So this height is common for both these two triangles, triangle ADE and triangle DEC. So area of triangle DEC equal to half into EC into DM. So we have got here four equations. Area of triangle ADE equal to half into AD into EN. Area of triangle BDE equal to half into DB into EN. Again, area of triangle ADE equal to half into AE into DM. Area of triangle DEC equal to half into EC into DM. We are going to divide the first two equations. Area of triangle ADE by area of triangle BDE. That is equal to half into AD into EN by half into DB into EN. Let us cancel half and half. EN and EN, we get area of triangle ADE by area of triangle BDE equal to AD by DV. Let us keep it as equation number 1. Then we can divide these two equations. Area of triangle ADE by area of triangle DEC equal to half into AE into DM by half into EC into DM. Here also half and half we can cancel. DM and DM we can cancel. We get area of triangle ADE by area of triangle DEC equal to AE by EC. Equation number 2. Now you see the right side of equation number 1 is AD by DB and right side of equation number 2 is AE by EC. We need to prove they are equal. That means the left sides also should be equal. If we have to get this AD by DB equal to AE by EC. Let us check the left side. The numerator position is area of triangle ADE in both cases. But the denominators are different. In the first case, the denominator is area of triangle BDE. Second case, the denominator is area of triangle DEC. If they are equal, we can say the right side portions are also equal. Now you see the figure again. You see the triangle BDE and the triangle DEC. Both are lying on the same base DE and both are lying between the same parallel lines DE and BC. Therefore, by the result you have studied in 9th standard, we can conclude their areas are equal. The triangle BDE and triangle DEC are on the same base DE and between the same parallels BC and DE. Therefore, area of triangle BDE equal to area of triangle DEC. Question number 3. So, these two left side portions are equal. So, the right side portions are also equal. So, from 1, 2 and 3 we get AD by DB equal to AE by EC. Hence the theorem. So, this is the statement. Here is given to prove construction. This is figure and this portion is proof. All the figures I have drawn to use for the proof is not the part of the proof. Dear students, I hope you understood the topic in this video. If you have any doubt, please comment.